Hi guys, in this video we're going to talk about all the different types of transformations. Now there are 4 types, and the first one we're going to talk about is reflections. So reflections, you always have a mirror line, and it's dead simple to reflect. You just count the squares to the mirror line, so 1, 2, 3, and you do exactly the same in the other direction. And take your time, every single point, so that's 6, and you just do 6 on the other side. I'm going to speed this one up, and it'll be there. And you just join them, and you're done. The difficulty comes when it's a angled line. So what I like to remember is you count to the line in any direction. So if I take this point, I can actually go to the right 2, or I can come down 2. And in this one, I choose to go down. Sorry, I choose to go right. And because I've gone right, I need to think about going at right angles. So I need to come down. If I went up here, it would be on the same side as the mirror line. So if I went right, I then went down. If I went down, I then go right. Again, the same amount of squares. So I do the same at every point. So count across, just make sure you do exactly the same amount down. Now, on a GCSE style question, you might have these on a graph. So this would be the line y equals x. Or the other way could be y equals minus x. And with the horizontal and vertical lines, they're often like x equals 2 or y equals minus 1, things like that. You shouldn't have too much difficulty with those. And there you have it. So a lot of people actually do this first point, get a bit confident, wrongly, and they draw this exact shape down here. But you'll see in a minute that's actually a translation, not a reflection. Now, rotation is so simple. We have tracing paper. So you put your tracing paper on, and there will always be a point for you to rotate from, normally on a graph. So you put your tracing paper on, you get your pen, and you draw round the shape. Now, you see my tracing paper is nice and straight. It does help. If your tracing paper is wonky, it's going to make it much harder for you. So you put your pen on, and this says 90 degrees clockwise. So think about what clockwise is, and move it 90 degrees. So once it's there, you just look at where it is. You can actually push quite hard through your tracing paper and it will appear on the sheet below. But it was there. It's always worth putting your paper back on and double check that you've got it in the right spot. Now translation means move. Okay, so you can't use the word move, we have to use the word translation. And we always show movement using a vector. So a coordinate shows a location on a grid. The vector will describe movement, but it works in exactly the same way. It's x and then y, alphabetical order. I see people put a fraction line in. This isn't a fraction, this is a vector. There is no line here. It's describing movement, not two numbers being divided by each other. So don't put any fraction lines in. So the x on the top describes the movement in the x-axis. So a 3 is the positive direction, so that means move 3 right. And the minus 2 on the y-axis is going downwards, so that means we're going to move 2 down. So you take every single point, you move it 3 right and 2 down. You take your time with it. So many people get these wrong because they do the first point like this, and then they draw it here. That's not 3 right and 2 down, that's a lot more. And just think, watch, 3 right and 2 down. So I'll show you another one. So again, this is the x direction first, so that's minus 4, so it means we're going in the minus direction on the x, which is left, and minus in the y again, so it's 3 down. You take your time, you count the points, and you move it down. I'll speed this next one up, and you just make sure it goes there. Now we're going to have a quick look at enlargement. So with enlargement, we are given a scale factor, so from a point. Again, this could be on a grid. So my advice is choose the closest point and work out how you get there. So always think about going along your grid lines, not diagonally through them. So that was 2 right and 2 up. And enlargement by a scale factor 2 means we've got to draw this twice as size and twice as far away from this point. So it's going to be in this direction somewhere and twice as big. So this journey to the closest point, if we're going to make it twice as far away, it becomes 4 right and 4 up. So it would be there. Now you can do, rather than multiplying the distance, you can just do 2 of them. So it would be 2 right, 2 up, another one because there's 2 of them. Again, scale factor 3, you would do 3 of them. Now, on our original, we have this line going along 2. So you can do this quicker by saying, well, 2 along, and I need to draw it twice the size. It's now going to be 4 along. And you can do the same going up from that new point. So it's originally up 2 is now going to become up 4, and fill it in. Let's do another one. So here's the scale factor 1/3. So it still says enlarge because it is an enlargement, but mathematically if something's 1/3 of the size, it's getting 1/3 of the, well, it's shrinking. So closest point, the distance there is 6 right and 3 up. So 1/3 of that becomes 2 right and 1 up. So that's what we're going to do. So from here, this line was originally 6. It's now going to shrink by 1/3 and therefore be 2. This line was originally 3. It's going to now shrink and become 1 because it's 1/3 of the size, and you can fill in. Now, a really useful technique is how to check. So if you join top left to top left and keep going, don't stop at the point, keep going, and do it with a couple of points, maybe all of them like that, you should notice that every single one goes through the center of enlargement. If that is the case, it's in the exact right place. If this doesn't happen, you have made a mistake. You need to rub it out and do it again. Again, bottom right to bottom right, top left to top left. You could do more, but they're all going through the center of enlargement. Now, this one is your higher tier, especially. This is a scale factor of -2. So exactly the same thing. That is 4 right and 1 up. But a scale factor of 2 would be 8 right and 2 up. But because it's a minus, we're going to go the opposite way. So now we're going to go 8 left and 2 down. So you're basically doubling it for scale factor 2 and going in the opposite direction to what you were before. Now this one you have to take your time. So it was this next point, 6 right and 1 up. So we're going to double it for the scale factor 2 and change the directions for the negative scale factor. So take your time, count the points, double check. So 4 right and 4 up is now going to be 8 and 8, left and down, which is there. So you're drawing your shape, and again you match up the corresponding points. You should see, once again, it goes through your center of enlargement. So that's every type of transformation done.